pencil in, I guess, right?
Well,
or that was the foxhole one.
That was the foxhole
Yeah.
one.
This Amateur Radio Roundtable is brought to you in part by ICOM America. All right. Good evening to everybody out there. This is Amateur Radio Roundtable. I'm Tom Medlin, W5KUB, and today is Tuesday, October the 8th. Hey guys, Tuesday, October 8th, that's my anniversary. I've been married to Kathy 25 years, man, so I guess I better not make the show run too long tonight. I need to run out and get her some roses or something, man. But anyway, hey, y'all say hi to Kathy in the chat room there, and I'm sure she would appreciate it there for, hanging around with me this long here. Hey, if you're listening to us on international shortwave on WBCQ on 5130, you can join the show and watch if you have internet. You can join the video and watch us on W5KUB.com. And if you're out there and you can shoot us an email to tom@w5kub.com and send us a signal report. Send us a signal report and let us know where you are and how you heard us. I think we got a good show for you tonight. Hey, Katie was going to be on, but she checked her calendar. She has to be somewhere early in the morning, and she's got a long drive tonight, so she's not going to be with us. Katie will be with us next week, and I think she wants to do some shack pictures next week, so post your shack pictures in the W5KUB Facebook group. We've got 8,000 members in that group, and Katie will probably pick out your shacks and show them on the show next week. We've got two ham radio legends with us tonight. We got Riley Hollingsworth with us, K4ZDH. You guys probably know Riley. He used to work for the FCC. He was the special counsel to the FCC on the enforcement side. And since then, Riley has retired, but he just can't get away from ham radio. And Riley is now involved in the volunteer monitoring program. So we're going to be talking about that in a little while. And we also have Martin Jue, K5FLU. Martin, did I get that right? The U on the end, right?
Yeah.
I always mess your call ups. I had another friend that was FL something else, and I always messed your call up. But anyway, we got Martin with us tonight, and you guys probably know Martin. He's the founder of MFJ Enterprises. So I tell you what, let's do first. Let's just jump right over. Well, let's just say hello to everybody first. Let's see, where'd Martin go? Let me look at this. And Martin, you're on here. Say hi to everybody, Martin.
Okay. Hello, everybody. I'm glad to be here tonight. And my call is K5FLU. That's K5 Funny Looking Underwears.
Now, what am I got going here? Something that was funny. I'll figure this out in a minute. I'll figure it out. Okay. I've got all kinds of stuff. Look at here. We got all kinds of stuff hitting right now, but we'll figure it out. Yeah, okay. All right. Look, we're gonna go back well, that didn't work either. We're gonna go back to split screen with you guys like that, and we're gonna talk like that. So, Martin, I'm sorry. I had 15 different camera shots all going at one time there. So, Martin, you're at home tonight taking it easy, right? You have a hard day at the office today?
Wasn't too hard. I had a good time. It was a good day. Got a flu shot. That was the big event.
Hey, that's good. I got mine last week. Cool, man. Glad you got it. All right. Well, hey, let's jump over to Riley, and we'll have to ask the obvious question. Riley, have you got your flu shot yet? Where'd Riley go? Riley.
I lost I keep losing Skype.
Do you? Okay. So the question was, Riley, have you had your flu shot yet? Boy, this is not good. Either he doesn't want to answer the question, or he's got internet problems. So we'll figure this out. Well, Martin?
Well, I got a call, I don't know, around lunchtime from the doctor's office saying they got their flu shots in. And so I said, I'll be over there because they don't get back from lunch until 2 o'clock. So I went over there at 2, and the whole office was full of people waiting for their flu shots.
Oh, man.
Yeah.
Well,
little towns are not like being up there in Memphis.
yeah. Well, at least you got your shot. I'm proud of you there. Let's see, Riley, are you there? All right, let me see if I can add Riley back to the call. This is not working out good. I think we've got internet issues with Riley. Let's see what happens here. Well, well, Martin, you and I may have to give Riley his talk tonight. Think we can make something up?
Oh, we can make something up. I was having internet problems myself.
All right, let's try him again here. There's a Riley there. Well, let's look at something here. There's 2 Rileys. Let's see if this helps. Sometimes we have a little trouble like this, and usually it clears up. Sometimes it doesn't.
Were you using the William? Or?
Well, I thought he used the William, but I saw the green dot by Riley, so I thought I'd try it. It says calling Riley there. Yeah, calling Riley. So I don't know, man. We can do a little of this while we wait, Hey, Russ, I don't think it's our producer's problem. We have a problem with, where is Riley? He up in Gettysburg or somewhere? I think we have a problem with Gettysburg tonight. Riley is unavailable, it says. We're going to try again.
What if you try the other one?
Well, that's the green one. That's the one that's saying he's online. So I will try the other one again in just a minute. Maybe the FCC just didn't want him to talk about this tonight. All right, let me try the other Riley. We may get the Life of Riley on here. Do you ever watch that, Martin?
Yeah, I remember that.
That may be who this is. Let's see.
That was a while ago too.
Yeah, it was.
I remember the Official Observer days. Do you remember that?
Oh yeah, I even got a card from them.
Yeah.
Did you ever get a card from them?
I can't remember. Seemed like I did, or I knew some people that got a card.
Yeah.
Our radios back then had so many harmonics.
Well, I got a letter from the FCC actually one time.
Man.
I think I was 3 or 4 cycles out of the novice band.
Oh, yeah, I can believe that.
Yeah. All right. Well, we're gonna see what happens here. We apologize to our viewers out there, but Riley was our first subject. I know that this is a subject that everybody wants to hear. Okay, it says 2 of 4 in a call. Martin, I'm thinking about hanging up on you and starting over, okay?
Okay.
Think we can do that pretty smooth?
Okay.
All right, here we go.
Okay.
I'll call you back.
Okay. Can you hear me?
I hear you. Okay, I've got you there, Martin.
Okay.
All right, I don't have your camera, but we've got you. So we've got half the group back together.
Can you see me? It looks like my camera's off.
Yeah, your camera is off, I think.
Okay.
There you go.
Gotcha.
We got you. Okay, now we got you. We got you. All right. 50% of the problem's fixed. Let's go and see if we can add Riley on here. We're going to add Riley. And all I got to do is go down to his name. Skype is really sluggish. Man. We're getting there.
There it is.
Let's try that one right there. We're going to click him. We're going to add him to the call. Here we go. Yeah, I think we need to insert another 25 cents in there to continue with our call here for sure. Okay, well, he's not answering that one. That one did say online. I'm going to try to add the other Riley on.
Okay.
And if we don't get him, we're going to continue with the show without him.
Okay.
Where'd he go? All right, we're going to add the other William on here. What kind of phone you're on a tablet, aren't you, Martin?
Yeah, I'm on the iPad.
iPad, yeah.
Yeah, it works good.
It does. It does. You know, I think Riley has some internet issues. He said it kept dropping off, so you'd think up in Gettysburg, they have pretty good internet service up there, you know?
I would think so.
Well, I'll tell you what, Martin, I don't think we're going to get him tonight, although he may try to call back in. If he tries to call in a few minutes, we'll do that. Let's just move on. And go through some other things, and if he calls in, we'll add him back in, and if not, we'll reschedule him, okay?
Okay.
All right. So, Martin, the last 3 shows or so, I built this little magnetic loop just for a kind of a proof of concept, just to see what could be done, I saw it's pretty simple now. There's a lot of skills, I'm sure, in technology that goes into building this thing, and I know you guys have got it down pat there, and you do a lot of things like heliarcing or welding the stuff together, which of course I didn't do. But I wanted to try. You see these people all the time selling these coax loops and stuff, and I just wanted to try to see what it took to build a loop, and if it looked feasible. So I tried the coax one first. It didn't hold its shape real good. Then I tried a 5-foot square metal copper pipe one. I didn't get just totally great results with that. And then I built one, with this cable TV hardline. That's like 7/8 solid aluminum, and it really holds its shape well. It's strong. And so I thought, well, for third try, we'll try that. So up until today, I was tuning the capacitor manually. I was tuning it manually, and of course, it was in the shack, and I thought, well, it might work better if it was maybe out in the open a little bit instead of right here in the shack. But if I've got it outside, I can't tune it, So I added a motor to it to remotely tune it. So I've got a few pictures here of a few things I did to this one, and I've got some technical questions for you. So,
Okay.
So here, let's see. Here's the capacitor, and I've connected just a little 12-volt motor to it there to turn it. And here's a little video here. It's going to show. How well it, how the motor will actually
12
tune
volts,
it.
it's
You
a
can
little
see
bit more
the
than 2
motor's got
RPMs a minute.
a very slow gear ratio. It's supposed to have 2 RPMs, and you can
Like
see it's
about
turning
maybe
the
3 to 4
capacitor
RPMs a
there.
minute, but that's okay.
And by, of
It's still
course,
a
reversing
fair
the current, I can
speed
turn the capacitor back the other way.
Tune. That's at 12
So,
volts. Let me
so
put
I
it
just
on,
put that
like
together,
6 volts, so we'll see
and
how
I
it
said,
slows
okay,
down.
well, just simply to
So I'm at,
control it, I've got to build me a little controller box, and I just used an old laptop, or I used a 12-volt power supply there, and built a little box here with a couple toggle switches on it. Very simple, 2 toggle switches in there, and basically that's it, and a resistor. So this little box right here, that's a soap dish that you can buy anywhere for about 10 cents. So anyway, I used that to run the power into, and I put some terminals on the back side of it there, to run out to the motor. So I took it outside, and you can kind of see it there. There's trees around it, but you can see I kind of lifted it up in the air, kind of just a little above the shack, above the roof here, and I could remotely tune it. So I thought, okay, I should get some pretty good results here. Now, one of the things I noticed, Martin, is, okay, if you look at the spectrum scope, this is using an outside delta loop. This is a pretty big delta loop antenna. I've got a circle there. There's a signal. You see the little signal there, the little peak?
Yeah.
Well, there it is, and that's on the delta loop. Now,
Okay.
when I go to the magnetic loop, look what happens. You can see the peak of the noise. When I tuned the capacitor, you can see the noise came up high. See right there, from about a third of the way in, you can see it kind of like a hill right there.
Which one is it now? What frequency is that at?
That's at 14,255.
255
Yeah, 14,255.
is okay.
So,
Circle.
So here it is on 14,255. There's a signal. There's a sideband station talking right there, and you can see their signal. I've got it circled.
Okay.
And then when I flip to the magnetic loop, you can see the noise. Once I get it tuned, you peak it for the loudest noise, basically. And once I peak it, you can see the noise level comes up pretty high right there. You can see kind of the downward on the left side. See how the noise goes down to low, and then up there at the circle, I've got the red circle, the noise is a lot higher. That's because it's peaked right there.
I see.
But here's a problem. This signal, let's say that signal right there, and you can see a good picture of it. Let's say it's 10 dB over 9, and the noise is quite a bit below it there. But when I go to the delta loop, when I go to the magnetic loop, the noise comes up, but the signal don't come up with it. It's like the signal doesn't increase, but the noise increased. You see the difference right there?
Yeah, that noise might be being picked up by something else, like the coax shell.
Well, that's what I'm trying to figure out. But I mean, when I tune it, the capacitor, I can move that noise from one end of the band to the other. You know, typically on I think a magnetic loop like this, your first step would be just tune for maximum noise. You know. And that's exactly what that is here. But when I tune for maximum noise, I don't have, the signal's not there. Now, I got a little video here. Let me show you. First of all, here's a quick video here about the little
remote control
case I
box. Very
built,
simple.
which
The
shows
switch throws in an extra resistor to slow
the
it down to
control
half
over it.
speed.
What I did basically, I got two switches. One
this
switch
moves it
will
forward,
reverse the polarity
counterclockwise or clockwise.
and allow
So
me to turn the
I'll
motor
press this
either
switch
way.
here.
The other switch
I'll press this
cuts
one.
it
You should
down
see it.
to like half speed, you know,
Should
for
see
like
the
fine
rotor there
tuning.
moving on the capacitor.
So there I am there. You can see it's
that's
turning
one
kind of
speed.
slow right there. If I
down
flip that
here,
switch there,
it should change the speed.
that will cause it to turn even slower.
We're about twice as fast now.
Okay.
So
So,
See, that is,
okay, so that's kind of where we are. Now, here's a video
That's, high
of the
speed.
actual receiving. I want you to look at the difference here.
And
Oh, here we go. I don't know if you
here's
can,
slow
I'll
speed.
try to turn it up where you can hear it.
slow speed now.
Okay, so I've got the loop outside on a push-up mast, about 15 feet in the air. I'm not very impressed with it. Here's the, this is a 40-meter delta loop. That's a 40-meter delta loop. I'm going to switch to the loop. To the magnetic loop. So I'm gonna turn it down. I'm getting some feedback here, Martin. So I'm gonna show you live on the air test. Now, right now I've got the delta loop on. You can see the noise level's fairly low.
When I flip
And
to the
you can see I picked out a
magnetic
signal.
loop,
The little
noise
blip
comes
right
up
there is a
real high, but
sideband
the
signal.
doesn't come up with it. So watch
So
this.
we're gonna flip the switch and select the magnetic loop, and watch what happens where that sideband signal is. The noise comes up. I think I'm fixing to flip it here. And you see the noise came up. The noise came up, but the signal.
That's the
Yeah,
delta
you got
loop.
something that's not right.
That's the mag
there.
loop.
What I
Mag loop.
noticed in the past is
Delta
even though
loop.
the signal's lower on the
Mag
magnetic
loop.
loop,
You can see
signal
the
to
noise
noise
level
ratio
comes up,
is much
but
higher.
the signal doesn't
Really?
come up with it.
Magnetic loop. Yeah, you got something not right. What it looks like to me, or at least one possibility, is that the coax itself is picking up a lot of noise. It shouldn't look like that at all. You should hardly hear any noise.
Yeah, yeah. And Kathy keeps saying I've got some feedback here. I'm not sure where it's coming from. Maybe it's off now. But you know, when I tune the capacitor in that magnetic loop, it peaks that noise. And it, of course, when you're not resonant, the noise is not as loud, you know. It's like it's peaking the signal, but it doesn't appear to be peaking the signal with the sideband conversation on it.
Well, do you have it oriented where you get maximum signal? Are you in a null?
Well, I also thought about that. I tried it on different signals. I was able at one point to actually hear the conversation on the magnetic loop, and you could see it on the scope versus a much stronger signal with the delta loop. Of course, I understand the delta loop is probably going to be, probably 10 dB higher anyway, because it's a lot of antenna. So I was able to hear a signal I didn't ever, after that, I was having such trouble with the on the receive, I didn't particularly try to transmit with it.
Okay, there's something not right. It may just be the loop's not oriented for maximum signal. You may be in the null of the loop.
Yeah. Well, I guess that's my next thing, to pull it back out, stick it back up there, and
known station. I mean, it looks like you've got it. Well, you got it on 20 meter band. Is there something known that you can just rotate the loop for maximum signal, and so you have a steady signal?
You know, when I had it hanging here in the shack, I could rotate it by hand. I could bring a signal in and rotate it by hand, and I could. It would get lower or get louder based on the orientation of it. I don't know that I ever had it null completely out. It'd be a little hard for me to turn outside, so I guess I just need to try some more experiments with it. And see what I can do. I think with this capacitor, I think I'm going to be limited to maybe about 10 watts or so, probably. You can see the spacing is not
Yeah.
not large here.
I'm talking about efficiency now.
Uh-huh.
That is the amount of power that you lose in the connection. That capacitor has a rotating contact.
Right.
If you use a broadcast band capacitor
Yep.
that has two sections,
Yeah.
and connect two sections in series, you can eliminate the rotating contact.
Yeah, and I'm aware of that. I just in all my capacitors, I don't have any with dual sections like that. Now, and I don't even have a butterfly. That other capacitor I had was a differential, and it tunes a little different. I think a butterfly would probably tune better, wouldn't it?
Yeah, a butterfly wouldn't have any rotating contact.
Right.
Just tell us, send you one. We'll send you one for you to play with.
Or I'll call Richard and we'll try that. We'll put one on there and see how it is. Now, you had mentioned that I would probably be better off if I used solid wire instead of that coax braid there, right?
Yeah, you would be, and you need to solder it. I mean, the shield of that coax, is that a solid, smooth aluminum shield?
Yeah, it is. It's just like a 3/4 inch solid aluminum pipe. So I won't be able to solder to it. But what I might can do is wrap that wire around it, and those are stainless steel hose clamps. I might can get enough contact by wrapping wire all the way around that pipe and putting that clamp on there really tight. I can get more surface connection.
Yeah, that's hard. That's hard to get a good contact. What I would recommend would be to go to Lowe's and get a piece of copper tubing, the stuff you use to. Yeah. Just get a little short piece of that as big in diameter as you can, so you can solder to it, because that makes a huge difference.
Well, Martin, I 3 weeks ago I showed I built another one. Here it is, right here. That's a 1/2 inch copper pipe right there.
Okay.
And I put a gamma match. I put a gamma match at the top instead of the loop. It seemed like it worked about as good with a gamma match as a loop.
Well, yeah, it'll match it good. The only problem is that it's unbalanced, and you get a lot of coax a lot of RF that comes back on the shield or the coax that come back to your transmitter.
Yeah.
It's better if you have it balanced and then convert it from balanced to unbalanced some way.
Well, maybe I need to do this, Martin. Now, I know a square loop is a little bit less efficient than a round one, according to my studies.
Well, and you're right. And the reason is the important thing is how much area that you enclose compare to the resistance. Well, it turns out that a circle encloses more area for the distance around the circle. In other words, the circumference of the circle.
Mm-hmm.
If you take a square to enclose the same amount of area, you take more length of the sides. And that's the reason the circle is preferable, because the amount of length is less for the same area that you enclose when you use a circle.
Well, maybe I should do this, Martin. Maybe I should play with this copper that I've got here, leave it as square. I'll get Richard to send me a capacitor, because I'm using the same motor-driven capacitor on all these. And I can solder to that copper. I can solder me some heavy gauge wire to it and then over to the capacitor.
Well, the problem with the capacitor is it's aluminum.
Oh, is it?
Yeah.
It doesn't have any solder.
No, that's the reason we weld it.
Oh, okay.
But if you could get somebody to weld some copper to the capacitor, then you can solder it.
Well, let me ask you a question. And I don't know about your operation down there or what you got going. I know you have some equipment down here. Could I maybe, if I get down here or something, or could you guys maybe weld me maybe a couple 2-inch pieces of wire on it or something?
Well, I don't know if we can weld copper to aluminum.
Oh, okay. I see what you're saying. Yeah.
What we can do is get you a 1-inch diameter tubing that's formed into a circle that's welded to a capacitor. But what we're talking about here is the efficiency of it.
Uh-huh.
You might have less efficiency, but everything else should work. When I say efficiency, that's how much power that you radiate divided by how much power that you put into it.
Right. So, Martin, what kind of power rating are your loops rated at?
Well, we rate them at 150 watts at the lowest frequency, but I have myself put 400 or 500 watts into those loops at a higher frequency.
Okay. Well,
you can put power into it at a higher frequency.
Yeah, what I was trying to do is, I want to see if I can get that picture off here. Let's see. Everything seems kind of weird tonight. Yeah, there we go.
You know, what you can do to help that efficiency problem is make the loop bigger. And if you just use the biggest piece of solid copper wire that you can use, you know, like 10 gauge.
Yeah.
They just get longer. That will have efficiency more than anything. And if you can't get it exactly into a circle, just make it as round as you can make it.
Well, you know, I might try that. So,
but the main thing is you need a capacitor that doesn't have any rotating contacts. That rotating contact.
Right. Now, would that also, since we're not putting any current through it on receive, you're not going to have a real voltage drop across it, but will that still affect the receive side?
It should not affect the receive signal much.
Yeah. See, I'm not having great results on the receive side with any of these, and I'm not sure why.
There's something not right, because on receive, it should work unbelievable. I think you may just not have that loop oriented. It may just be in the null part of it.
Well, I'll have to pull that thing back out of the shop again and play with it a little bit more.
Yeah, put a rotator on it. And just
I mean, I've got a rotator out there for my satellite stuff, but it's 100 foot away, and
Yeah. But you might want to just get a small utility
You know what? Yeah. You know what? I can outside my window here. I can just put it up on a push-up mast and hand turn it right through the window. Yeah.
Yeah.
Yeah, I can do that.
Yeah, that's what we used to call the Armstrong rotate.
That's right. That's right. All right. So I'm going to try that, and I'm going to play with that because, you know, I've got my son is in his HOA down in Austin, and you know, I wanted to kind of see how a magnetic loop would work, and see if we felt confident, you know, how well it was going to perform before we even thought about doing anything like it. Because I don't know. I mean, you know, you're the expert on magnetic loops. I know you sell them there. I don't have any real experience with them. I got to believe, of course, they're not as efficient as a nice outside antenna, you know, but.
Well, it can be. Have you ever seen our loop tuner?
No, I bought him one of your regular tuners and sent it down there, and we just put a wire over the roof, you know, and a counterpoise there, you know, in the house, and he's using that tuner to tune that random wire that's over the roof.
Well, loop tuner is completely different.
Uh-huh. Now you use a loop tuner. I think you use one when you travel, don't you, like at a hotel?
Yeah, it's got a butterfly capacitor in it, so no rotating contacts, and then a matching capacitor, and you basically just hook a wire to it and just loop it around whatever you can loop it around. The curtain, a door, make it as close to a circle as you can. Then you just turn two knobs until you get maximum power out. And I've used it when I travel, and it works great. If you go to like a Airbnb where you're, you know, outside in the high, it works really good. If you go to high-rise hotel, then you're inside a hotel and you pick up all that electrical noise.
Yeah.
But
I wonder how it would be if he actually put a loop of wire against the inside wall. I mean, actually, it'd be the outside of of his house, but because I don't think he's got but one small window in that shack, and if he just circled the wall on the outside of the house and tried that tuner, do you think that would actually work?
Yeah, it'll work great. You can put it on the inside of the wall and it'll work great.
Well, that's what we're talking about, keeping it on the inside there.
Yeah, it wouldn't hardly make much difference if it was outside or inside.
So if he could get a loop, say 8 foot up on the walls, typically are 8 foot. So if he could go up 8 foot and go across maybe 10 foot and come down 8 foot, and then come back at the floor and connect, he would have 10, 20. He'd have about 38 feet or so in the loop, probably.
Well, if you keep the circumference of that loop to pretty good bit less than a quarter wave in a tune. So on 40 meters, you don't want to use more than 30 feet of wire or so. Less than 30.
I was reading about the magnetic loops. One of the definitions of the magnetic loop is it's got to be, I think, less than a quarter wave. At least I saw that somewhere.
Yeah.
So this loop you're talking about, now will that tuner tune it for different bands, the same piece of wire?
Yeah. It'll tune it. I think like over 3 to 1 frequency range, and you can operate almost any band just by adjusting the length of that piece of wire. You can operate 160 meters if you make the wire big enough. You can operate 80 meters if you make the wire big enough.
How large of a diameter do you think you would need based on your experience, let's say for 80?
I can't remember now, but it seems like I remember if you take a piece of wire like 12, 13 feet long.
Yeah.
And you can operate from 40 meters up.
Okay. Well, I mean, 13 feet's not very long. I mean, that's going to make a circle of about a little over 3 feet.
Yeah.
I mean, it's not very big, you know.
a 3-foot loop, you can operate 20 meters up. If you make it larger, it will be more efficient on
Yeah.
60 meters and 40 meters. Loops really work really good. Let me just give you an example. The loop that we have is 30 inches in diameter.
Uh-huh.
It's a piece of aluminum conduit that's 1.05 inches in diameter.
Uh-huh.
Okay. And then the diameter of the loop itself is about 30 inches. Well, that with the capacitor we use, which is all welded with no rotating contacts, the efficiency on 20 meters is calculated to be 62%. What that means is if you put a dipole up, a dipole is almost 100% efficient, 98, 99%. So you put a dipole up, if you radiate 100 watts, and you take that loop, that 30-inch loop that we have on 20 meters, then it's radiating 62 watts compared to a full-size dipole. Well, that's less than 3 dB, and you can't even hear the difference. Somebody who's listening to you can't even hear the difference. And we're talking about a 30-inch piece of loop compared to a 33-foot piece of wire.
Yeah. Now, is the wire? I guess you're still going to have the voltages on that wire that you'd have on a aluminum loop, right? It's still going to be high voltage.
Oh, the voltage on that loop is like 15,000 volts.
Will it be that on it? Would it be like that on a wire with your loop tuner?
Well, the watt, you're talking about a dipole wire? Or the wire
No, I'm
on the
talking.
loop?
I'm talking about just if he was able to put just a piece of insulated wire around the wall and hook to a loop tuner.
Well, the voltage would be where the capacitor is. That's where it's connected to the capacitor.
Okay.
Now, if there's losses, the voltage would be less. But yeah, there'd be a lot of voltage on there. But
yeah. So do you ground that loop tuner you got, or is it just kind of floating out there?
Well, at the center of the loop, opposite the capacitor, you can ground that with no problem, with no effects.
But I mean, you're not going to get an RF burn or anything like that if it's not grounded, are you?
No. There's no RF problems if you don't ground it.
Yeah,
But
you're talking about a high voltage at the capacitor ends. So I
That's
was
right.
worried that this loop tuner might have some real high voltage around the box,
Well, okay, what we do is we put the capacitor up in the air where nothing is around it.
Uh-huh.
And the coat spot is down at the bottom where you mount it.
Now, I'm talking about the loop tuner, not your not your loop.
Oh, okay. No, the capacitor itself is isolated.
Okay.
Everything is isolated. There's high voltage isolation around that capacitor.
I got
So
you. Yeah. Okay.
there's a chunk of fiberglass insulation. In fact, the way that we build that loop tuner, the capacitor itself, the post that connects to the capacitor,
Uh-huh.
extends outside of the box so you can make the connection. So there's no insulation except at the capacitor itself. But you're right, you don't want to touch that loop,
Okay.
loop capacitor.
I'll tell you what I'm going to do. I'm going to go ahead and I'm going to open the phone lines up here since we lost Riley tonight. We'll have to reschedule him. I think he was having some internet issues. But we're going to open the phone line here, and we'll talk about a lot of different things here. I was going to actually, I have a lot of people. Martin, I know you have taught engineering and different things there at college, and a lot of people ask me things about Ohm's law and how can you remember all the different Ohm's law and stuff, and basically and to build this little box here that controls my thing, high speed, low speed, I basically did something very simple. And again, if people are interested, how do you reverse the motor? There's a little diagram right there. It's a double pole, double throw switch. It just reverses the current at the motor. And how do I get half speed? Well, if you look at switch 1 there, I've just got a resistor in series with the motor, and you just calculate the resistance to try to get, you know, the speed you want. And in this case, I wanted to cut it in half. So basically, when that switch is closed, we got 12 volts on the motor. You can see on the little diagram on the left there at the bottom. When that switch is open, we've got 6 volts on the motor and 6 volts across that resistor right there. And that's just very simple way that I'm controlling my motor. You know, this is not, what do you call it, stepper motors or anything like that. What do y'all use? You use motors in your loop, don't you?
Well, we do. We've got 2 kind of motors. One is a DC motor, just like yours, and it also has a gear reduction box, which yours also has in it too.
Yeah.
But normally those motors don't draw anything near 100 milliamps. They're just in a few milliamps, and you can use a 9-volt battery with them.
Yeah, I did check this one out. I ordered this from China, you know, and it's pulling somewhere around 90 milliamps at 12 volts.
Okay,
So
motor probably has got lots of torque on
it. Yeah, it probably does. So so anyway, I calculated, you know, and again, Ohm's law, and people say, how do you remember Ohm's law? And you know, you may have taught it this way too, Martin, but here's the way when I first started electronics, here's how I remembered it. It was a little triangle, the E and an I and an R, and you put your thumb over one. Did you ever use this?
I've seen it.
You put your thumb over, for instance, it's just, all you gotta do is remember this triangle, E, I, R, and put your thumb over, like look at the bottom down here. You see the I, the red I, put your thumb over that. So I equal E over R. And then if you go over the other one, put your thumb over the E, and E equals I times R. And on the other one, put your thumb over the little red R there, so R equals E over I. So you don't have to remember 3 or 4 different formulas, man. You just remember one, and you got them all here if you put them in the right order, you know.
That's very neat. The way I learned was I was equal to E over R, and then just use algebra to calculate the other ones.
And you just have to, I mean, there's some basic, basic math here where, you know, E over R means E is divided by R. And like down in the middle there, E equal IR, that's I times R. So there's just some basic stuff here. But basic, simple things like this is what, you know, basically I used to calculate the resistor there. You know, I knew I had 100 milliamps of current here. And I wanted to go from 12 volts to 6 volts across the motor, so that means I want to drop 6 volts across the resistor. So just plug it in and into that formula, and it'll tell you exactly. I think it said I needed 60 ohms. That would be 6 volts divided by 100 milliamps is 6 volts.
No, and that's pretty clever. We use that picture of pi.
And of course, pi, you got to think, okay, I'm going to put a resistor in there. It's going to drop my voltage in a series circuit. And you think, okay, man, is that thing going to get hot? Is it going to start smoking on me? I mean, what kind of wattage do I need? And I was surprised. I mean, it's very low wattage there. And again, your formula for power or wattage is P equal I times E. And when you put 100 milliamps times 6 volts, you get 0.6 of a watt, so it wasn't a very big resistor needed.
Yeah.
To do that.
Yeah, especially when you're just turning that motor just for a little short time. It might get hot for a little short time, but it won't hurt it. Now that's pretty neat.
Yeah, let me see if let's see. Let me start the phone here real quick. I thought I already had it started. Let me put the number up there. And we'll just take some calls tonight.
You know, I got an email from the other week when we were on from W9NUQ.
Oh, did you?
Boy,
Okay.
yeah, very nice. He was
Well,
telling
cool.
us about what how he likes to operate.
Uh-huh.
Nice little. He may be listening, watching us tonight. If he is, call in.
Yeah, this is a chance to call in. I got a couple emails too that said they were unable to call in, but they sent me an email, so that'd be kind of cool. So hey, there's our number, and for you guys international out there, I'm gonna post a link for our international numbers. So there's a link right there for international phone numbers. So we've got numbers in 65 countries. You can give us a call. Well, you know, Martin, we're going to have to work on getting Riley some kind of backup communication service up to Gettysburg.
Well, that's pretty amazing, isn't it? You would think Gettysburg would have much better internet than
Yeah,
we have.
you would think so, you know, but who knows?
But I sure remember the official observer program that we had back in the 60s. And I think you do too.
Yeah, I do. I got a card. Who's on the phone?
Ah, sorry, the thing figured out yourself, so I did.
Yeah, who's on the phone here? Let me see if I can get your audio cranked up here. Who's talking?
Yeah, this is Kilo India 7, Papa Kilo Lima. My name is Roy, and I'm in Portland.
Okay, Roy in Portland.
Yeah,
Hey,
Portland, Maine, and Portland, Oregon.
How you doing? How you doing, Roy? Hey, Roy, I know
Yeah.
you. Hey, Roy, you got a
Yeah,
guitar. You
yeah,
got a
that's
guitar, don't you?
Yeah.
You're the man.
Yeah.
You're my rock guy.
Yeah, there you go. Yeah.
All right, man.
Hey, really enjoying the show tonight. I know you guys had some technical difficulties in the beginning, but I think you found a good replacement here. Talking about this, especially about this loop tuner thing. I've really been curious about that for a long time. And now I can ask the guy that knows. Is this thing when you tune a wire with that loop tuner? Is it more like a conventional antenna, or is it more like a magnetic loop antenna?
Or it's a true magnetic loop. You want to make it, you don't want to make it too long, less than a quarter wave where it can still tune it. Are you in Maine or Oregon, Roy?
He's
I'm
in
in
Portland, Oregon.
Oh, in Oregon. Wow, long ways off.
That's right.
Yeah. I can never hear you guys on the 14 meter net, although I tuned in on WebSTR in Utah. Tom, I can hear you booming in Utah, but not here.
Oh wow, yeah.
Really keep trying though. In winter, maybe I'm determined to pick you up. At least hear you, if not be able to check in. So
Well,
we're gonna keep trying that.
I tell you, Martin kind of laid the secret on me. Martin told me about his extended double ZEP antenna, and I just had to have one. So I built one, and I stuck it up out there, and I don't know. I seem to be getting great signal reports everywhere with it, so I'm happy.
I don't have an extended double ZEP lot. I have more of a magnetic loop type lot. So
Oh yeah? Well,
I might have to, I may have to try that loop tuner. I've always been fascinated with it, and this is not helping. This is only making the addiction worse. So, I've been trying lots of different kinds of antennas here. At least as many as I can afford, and that might be one of the next ones on my list.
well, I'm about to think. I'm about to think that the loop tuner might be an easy way to go, because the experience I've had so far building 3 different loops, and I know I'm not technically doing them to perfection, like Martin says. This thing works down into milliohms, and there's a lot of loss on these connections. But I'm kind of thinking that maybe a loop tuner might be the way to go with it. That might
Well,
be the
you-
next. That may be the next thing I want to try out here and see how it performs. That may be the answer to a lot of people's questions. You know.
Now, can that be tuned remotely? Is there like the one that MFJ makes? Is there like a remote, like you were talking about with a little motor and everything, or do you have to have the loop tuner to do it?
Well, that loop tuner's got a knob. You have to turn it by hand, but it's got a reduction drive on it. But the loop tuner's got a current meter in it where you can tune the loop for maximum current that flows through the loop, which is what gives you the radiated power.
Well, that's cool. Hey, I guess you could always put your little gear reduction motor on it, mount it on a board, and
I suppose you could.
put your motor on it. But you wouldn't be able to see the what is it, Martin? Is it like an RF amp meter?
It's an RF amp meter, but you could use a field strength meter.
Yeah.
Where you are, and just tune it for maximum field strength. That's really what you're after anyhow.
Well, couldn't I use my antenna analyzer to do something like that? Just for feeding rather than transmitting?
If you use it in a field strength mode, you can. But a relative field strength meter, all you need is a meter and a diode. You can just use your multimeter with a diode.
Oh, okay. Oh, really? I didn't know it was that simple. Okay.
That's all it is.
Yeah. Well, Martin, I've back during the war, and a lot of the war surplus stuff that came out after, I got my novice license, or before I got my novice license, a lot of stuff, the old transmitters had RF amp meters in them. And I always looked at that. And I guess they just tuned it for what, maximum RF? They're in the antenna? And
Yeah, the current is what makes everything radiates. The more current you get into the antenna. And those RF amp meters were really thermocouples. They just heat something up, and that generated a little bit of voltage, and that voltage is what you read on the meter.
Yeah. I meant RF current, RF amp current, RF current amps, whatever. Yeah.
You pass amps through
Yeah.
a thermocouple piece of bimetallic metal, and when you heat it up, it generates a little voltage, and the meter will read the voltage across that junction, and that's how they determine what amps were. But the more modern ones uses a transformer, current transformer.
Uh-huh.
It's just a toroid with a wire going through for the primary, and then the toroid's got wires, turn the wire wrapped around it, then you rectify it with a diode, and then you read the voltage.
And you go to a meter, huh? And that's reading now. I guess that's reading current, right?
Yeah. That's a current transformer. So you transform
Yeah.
the current. Yeah, so you can read it and then convert it to voltage with a.
Is that basically how your loop tuner operates? You use like a toroid and a meter.
Yeah. We've got
to
several versions of that loop tuner, and the one of them uses a current meter, and then there's another one that, in addition to the current meter, which is the basic thing, is an SWR meter, so you can tune both of them together.
Okay.
Current minimum SWR. It's pretty neat. You would love that thing. It's
What?
just a box. You connect two wire to. You take one wire, connect both ends to it.
Yeah.
You loop around something, you tune it, and depending on the length of the wire, you can operate any band. You want to operate 160 meters?
Yep.
Put a wire on there long enough.
Well, Martin, that may have been what we needed to do instead of go with just a random auto tuner, probably because we're trying to keep this thing hidden pretty much. And so I think that's probably our next step is going to be play with a loop tuner and see what kind of results we can get there. There was a question about the magnetic loop. Is it vertical or horizontal? I guess it's a horizontal, isn't it? Mainly, or
And you can use it either way, vertically or horizontally. I would recommend using it vertically.
you talk about standing the loop up and down.
Yeah, just
And
stand
that
it
would
up.
that would give you a does that give you a vertical polarized signal?
It gives you a pattern that looks just like a dipole.
Okay.
Just two loops. And so it's directional, just like a dipole would be directional. If you mount it horizontally, then it's omnidirectional, but then it's greatly affected by ground. If you mount it vertically, then ground doesn't affect it very much. I used to use it on the floor of my living room, leaned against my couch, operating QRP. I could work into Europe. Of course, this was back in the days when we had really good propagation. I used our little 5-watt radios with that loop, leaning against the couch on the ground floor. I could work everything.
Well, that's interesting. And you didn't set anything on fire.
No, kept that capacitor out of the way.
I guess that is a risk that people have to be careful about, right? I mean, you could generate enough voltage here. You could probably cause some arcing or a fire, possibly.
Well, you could very easily.
Some of these things, yeah.
I mean, if you run 100 watts inside your house, man, everything will start to absorb some of that RF current. You'll set everything on. Your fire alarm, everything.
Yeah, well.
Lights up. It's better if you take that loop and take it outside. You put it inside your house, everything couples to it. And everything couples from the house into the loop. So you pick all kind of stuff up.
All right. Well, Roy, it sounds like you need a loop tuner. Are you still there, Roy? He may have hung up on us. Do we have somebody else on the phone?
Hey, Tom.
Yeah.
WZ1L here.
Hey, Bill.
Hey, Bill.
All right. Martin. All right. I'm teaching a general class, okay? And I went over I guess one of the slides there that came from the ARRL, talking about recommended signal separations. Supposedly CW is 150 to 500 hertz. Sideband is approximately 3 hertz. RIDI is 250 to 500 hertz. PSK is 150 to 500 hertz. My question is AM operations. Do you know anything about AM operations?
Time.
I would say AM is going to be twice the. If you talk bandwidth, today your sideband bandwidth is pretty much limited. I think on your transceivers at about 2.6 kilohertz. I think they've really cut it off. In fact, the new 7610 I've got, you can't expand it any past that. If you want to have a nice sounding high fidelity signal, you can't turn it up past 2.6 K. So it's just your sideband signal is going to be either a lower or upper sideband, but your AM signal is going to be both those sidebands. So I'm guessing your AM signal bandwidth is going to be, what do you think, Martin? Close to 5 kc?
Yeah. I mean, radio's now limited to 2.1 kilohertz per sideband. So it's twice that. But AM broadcast band, I think they're limited to 10 kilohertz.
The AM broadcast, okay. Well, K5 TGT in here says 6 kilohertz. That's sideband times 2. That's considering you got a 3 kilohertz sideband. Mine won't do that. Mine only go up to 2.6. So I'm at 5.2 if I double mine, but you know, Martin, I know you operated back in AM days. I operated back in AM days. 6-meter AM was a lot of fun. But I've never been one of these persons to go for high fidelity. I mean, in my ears, I can hear sideband. It sounds just as good to me as some AM. I mean, what do you think?
Well, sideband sounds as good to me too, but more because I can't hear very good anyhow. But there's a big group that loves the high fidelity of AM, and you know that's how we grew up.
Yeah.
There's some disadvantages of AM. It just takes a lot of power. Whoops.
Uh-oh. You must have got too close to the loop antenna there.
I did. I'm going to stick it back up here. Had a can of water that spilled. But,
oh, you had some water?
Well, not all of it is water.
Oh, okay.
Some of it is.
Some of the ice is melted, huh? Yeah. Okay. Well, yeah, you know, hey, I just like to, I mean, everybody has different parts they like, you know, I'm sure, I mean, there are still people that stick with the AM. They think it sounds the best, and they strive for that sound, and that's okay, but, you know, we can sure get a lot more sideband signals on the band than we can AM, for sure.
Well, there's so many facets.
Yeah.
There's
Before I go, I just have a question, I'll pass a question that Brett WY7BG asked in the chat room, and I don't know if it was addressed. The question is for Martin. He said he just got a Zigu G90 for which he is, oh wait a minute, yeah, he's the U.S. distributor. He wants to know if they're going to continue to improve the rigs via software updates, and will MFJ be selling accessories for it? Any way to improve its handling of QRN? The internal noise blanket is currently worthless.
Well, we really have to depend on Zygu and what they decide to do. Our role in all this is just to make it available to everyone here. And we have some input, but you know, it just depends on whether or not they want to listen to us or not. You know, that's how the, you know, that's just how the world works now.
Martin, I guess so.
Well, I just thought I'd throw that question to you from Brett.
And what was the hey, Bill?
You.
Bill, what was the complaint? Was it what filter or something what didn't sound good?
Yeah, the noise blanker supposedly.
Oh, noise blanker. Well, you know, I guess you could probably add, I know MFJ has a noise, noise reduction box, don't you, Martin? That could go in there externally.
Yeah, the 1026. 1026, right, Martin?
Yeah, you know our numbers really good, Bill. When you come back down here so we can go to Obie's and get some of that Louisiana food, you and Tom come down.
Yeah, well, I'm going to do that soon. Well, hey, you know, a good noise filter.
We'll have to make another trip down there.
You know, a good noise filter box like they sell. I know MFJ sells one, and I think BHI or somebody has one. But, you know, I guess you can put that outboard, and my understanding is those things do a great job in taking noise out.
Tom, can I talk about that just for a minute?
Yeah, go ahead.
Okay. It really is a device that cancels out RF noise before it gets into your radio and cause problems. It's not a filter that tries to filter this out.
So does it go on the RF side or does it go on the audio side?
It goes on the RF side before it even gets into your radio.
Oh, okay.
Right,
between
right.
antenna and your radio. And what it does is it takes two antenna input. One antenna is your normal radio antenna for transmitting and receiving. Then it takes a separate, smaller, easier to put up noise antenna. The main antenna picks up the signal and the noise. The smaller antenna picks up the noise, as much of it as you can. And then the box itself adjusts those two signals from the antenna. It adjusts the magnitude, and then it adjusts the phase. Now, when I say phase, what I mean is that it adjusts it 180 degrees out of phase and the same magnitude where for the noise, where the noise cancels out and it leaves only the signal. So all you have is the signal going into your radio and the noise being canceled out. So it can't cause any problems in your radio because it's not there. But it requires fine tuning and turning knobs. But once you get it adjusted, it's pretty incredible. I mean, let's take, for example, just say if you tried out on a 2 AM broadcast band radio stations that you're listening to, but they're exactly on the same frequency on the broadcast band, where you can null out one station totally and on the same frequency and listen to the other one. That's how effective it can be.
That's interesting. Right. I was thinking more. This was now you also make a an audio filter box, right? That goes on the audio side.
We do. We make several. One of them is a DSP.
Right. That's what I'm thinking of. Yeah.
Okay. Well, the DSP filter is just incredibly versatile. It has a brick wall response. What that means is when the signal encounters this wall, it just disappears on the other side of the wall. And you can configure that filter as a low-pass filter. What that means is everything below a given audio frequency, let's say 2 kilohertz, will be passed through, and anything above that would disappear. You can also configure it as a high-pass filter where everything above a frequency, say 500 kilohertz, will pass through, and below that, like hum and noise, would disappear. And then you can make it where both of those filters are in effect, where you can adjust the low frequency cutoff where nothing passes below that, and the high frequency cutoff where nothing passes above that. And you can shift that around in the entire audio band to make it into a band pass filter of any pass band that you want.
So Martin, how does that compare with the filters that are in, say, your 7300? Or is that similar? Because you can do top end, bottom end,
That's same thing at audio frequencies. It's a DSP filter, and the filters in the 7300 are DSP. I'm not sure what frequency their filters work on.
Okay. Because I know people that have bought some of these audio filter DSP speaker boxes. I mean, they do wonders. I mean, they can take noise just completely out, man. I mean, it's
it's unbelievable.
Yeah.
This filter we have also has a mode for noise reduction, just like that. It's all in one box.
Okay. An added thing here from Brett here. He says the noise blanket cuts the audio rather than actually filtering the noise, and the rig goes silent.
Well, you're right. A noise blanker, what it does, the kind of noise that a noise blanker works on
or impulse noise. These clicks, and they're just little sharp peaks of noise. So what a noise blanker does is it just turns everything off during that time when that noise appears. So you don't hear anything during that time. So there's a bunch of holes in there that you can't hear anything on. That's what the traditional noise blanker does. And noise blankers have been around for a long time, and they're more of an analog device. I don't know about the newer ones, but the original ones and the older ones, they just put holes in the audio signal where you can't hear anything when that occurs.
Okay.
Okay. Well, thank you for answering the questions there. I don't see anything else from him, so I guess we covered what he was looking for.
Well,
thank you, Tom, for letting me call in.
Yeah, Bill.
As always, and happy anniversary to you and Kathy.
All right, thank you. Thanks for calling in here, man.
Thanks for
Thanks.
calling.
All right. Goodbye.
Yeah, and I am
Martin.
ready. I am ready to come down here to Obie's and get a good meal there at Obie's, man.
There's always, we'll try some stuff you haven't tried.
Yeah, is there somebody else on the phone? Is there someone on the phone?
Yeah, man, I'm here. I'm just reading the mail, W8LV.
Yeah, who is that?
W8LV.
W8LV, right?
Yes, sir.
Yeah, okay. Hey, I think you checked in the net tonight, man. Thanks so much.
Oh, thanks for having the Thanks for having the show.
Yeah. Now, is this the first time that you actually visited the show?
Oh no, no, I've been on this line before with you.
Okay. Okay. Cool. Very good.
Yeah, we're just listening to you guys talking about the interference and splitting it up. I wish Martin would make an adapter for headphones so that you could listen to radio split without having to do anything special. Just plug the adapter in and be able to make any set of splits in it.
You're talking about an adapter to go from like the little 1/8 inch jack to a large jack, or?
No, just so you can split the two sides.
Oh, I see what you're saying.
Run it as a split set.
I see what you're saying. That way you could listen to one radio station in one ear and one in the other ear, right?
Yes, sir.
Yeah. Okay.
That sounds good.
Well,
good.
Martin, I think the 7610 I've got, of course, it's got the stereo type earphone jack on it, and I think, if I'm not mistaken, I think they pipe that into like left and right ears. But
Okay.
I think if I've got the second receiver on, the dual receiver, I think it's like what W8LV is talking about. It would come in, one receiver would come in one ear and one would come in the other ear.
No, I think that'd be very nice. That would work for lots and lots of people. It won't work for somebody like me because I can't hear out of but one ear.
Well, I would probably get confused there, but I guess if you're monitoring another frequency or something, it'd be kind of cool to have.
Yeah, well, your brain can distinguish between two different signals like that.
All right, now W8LV,
Well,
where are you? Well,
Yeah.
I'm sorry.
where are you located? I forget.
I got my MFJ catalog, and I looked for a split set adapter, and I couldn't find one. So
Now,
I knew Martin would probably build one.
I think we got one.
And
I think we
also
got
to
one where
everybody.
you can turn a knob and you can put as much of one in one ear that you want.
That's Hardy.
So Martin thinks he has one. Now, he's only got like 10,000 items in his catalog. I don't think he remembers every single one, but he thinks they got something like that. So we'll just have to dig in and see.
Where are you in Ohio?
Yes, I'm in Central Ohio.
Okay. What's your name? I got your call, but I don't know.
Bill, W8LV Bill.
Bill.
All
Okay.
right. Well, guys, I am so sorry that we just wasn't able to bring Riley in tonight. I don't know what's going on. It might have been computer problems or Skype problems on his end or something, but we'll reschedule that. But it's always fun to talk with Martin here about all these things here. There's so much I want to try and test and do, you know, and it's always fun. And Martin, boy, hey, the net tonight, Martin. You said did you hear me or not?
I did hear you.
You did
and
hear
I
me?
heard those who were working you, but you were kind of weak. You know, you're so close to me, and
Yeah.
that night the band's kind of long, and I would have gotten on, but I didn't have a microphone plugged into my radio.
Well, you could call me on
Where it
CW.
was.
You know, just keep it down at a decent speed. I know you're probably pretty fast there.
No, I'm not fast.
So yeah, you know, the net started out, boy, the band was just really crowded tonight at 5:30, and it started off real low. You know, we had one or two check-ins, and we talked for a while. But boy, toward the end, it was starting to be pile-ups, man. I mean, there were like 4 and 5 and 6 people calling every time. So it really livened up tonight before the net ended.
Man. Yeah, that band goes long about the time the show starts.
Yeah, well, you know, and I've been on there at this time in the evening, and we've had people from Australia call us on 40, and even South Africa.
Wow.
Yeah.
That's pretty incredible. I put my mobile rig back in my car and put the antenna up, and I heard on 20 meters, my antenna is low enough where I can drive into the garage. What I did was took one of our short ham sticks, and I think this is either a 15 meters or 12 meter ham stick, and put a long whip on it so I wouldn't have to use so much coil to make it more efficient. But it's short enough where I can drive in and out of the garage. Nobody was on the band. This guy from Belize, V31 JW, calling, and there were people all over working them. So I gave him a call, and he came back to me. He was the only guy on the band.
Well, the band was open, but just nobody was using it, and I'm finding more and more that's the case.
Yeah.
I think if you get on there and call CQ, you might get an answer on some of these bands. Now, you start getting up really high bands, you know, the 6 meters or 10 or whatever, you might not. But these other bands, like 17 meters, when it appears to be dead, I think there are people out there.
Well, you know, if you listen when the contest is going on.
They're everywhere.
Everywhere.
Yeah. Yep. Well, you know what, guys? It's almost 9:30. I think we probably ought to just go ahead and end the show tonight. We've had a good discussion. We've covered a lot of neat things here. I want to thank Martin for being on here tonight. If he wasn't here tonight, yeah, you guys would have had to just stick it out with me, and that wouldn't have been very good. But
happy anniversary, Tom.
Well, thank you. Next week, Katie will be back with us. Who knows? We may reschedule Riley back next week, but Katie will be back next week, she said. So we're looking forward to that. We always have a great show when Katie's on here. And also, Martin, you're welcome. Anytime. We don't want to take all your time, but it's always good to have you on here whenever you can make it. You know.
Well, I appreciate being on your show, and I always enjoy visiting with all the hams there. And I'm just like all the rest of the guys, just like to get on air and just have a good time. I'm not any big contester or DXer. I just like to get on and
Martin, did you ever get a DXCC certificate or anything like that?
No, I never did anything.
Yeah, I didn't either. Martin, I bet you I've got 1,000 QSL cards from all over the world. I have never got a certificate for DXCC or work in 100 countries or, worked all continents or whatever. I never really was interested to send anything in and get that. I don't even have a worked all states and been a ham for 55 years,
Yeah. I just like to get on and talk to people.
Yeah, I do too. Well, all right, Martin, next time you get to Memphis, call me and come by.
Okay.
All right.
I appreciate that. And I hope everybody have a good evening tonight.
All right. Well, I'm going to go ahead and we're going to close the show down. Thank you so much, Martin. And everybody, don't forget our 40-meter net on Tuesdays at 5:30. Join our Facebook group. It's called W5KUB. We've got 8,000 hams in the Facebook group. And help spread the word about our show here. And if you got any suggestions for topics, shoot us an email. I'll be glad to hear from you. And even if you'd like to come on the show with something, we'd love to have you. So I'll say good night to everybody. I'm going to say good night to Martin. Martin, I'm going to go ahead and hang you up.
Okay.
You can go to bed now, and I will see you later. Thanks.
Okay.
All right, so we got rid of Martin there. We're back to here, and again, thanks to everybody for showing up tonight. Sorry about the connection with Riley, but we'll make it. Okay, let's see. I need to do this real quick. Heard it, worked it, logged it. It's time to get the transceiver that's best suited for your lifestyle. ICOM offers a variety of high-performance and innovative products. Make the most out of contesting with one of these ICOMs today. The IC7610 is the SDR every ham wants. This high-performance SDR has the ability to pick out the faintest of signals even in the presence of stronger adjacent signals. The ICOM 7610 is a direct sampling software-defined radio that will change the world's definition of an SDR transceiver. It has 110 dB RMDR, independent dual receivers, and dual Digiselect, changing the way entry-level HF is designed. The IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. It has RF direct sampling, 15 discrete bandpass filters, a 4.3-inch color touchscreen, real-time spectrum scope, and an SD memory card slot. The IC7851 allows you to keep your competitive contesting edge with faster processors, higher input gain, higher display resolution, and a cleaner signal. ICOM's IC7851 is a pinnacle of HF perfection. It has dual receivers, digital IF filters, memory keyer, digital voice recorder, high-resolution spectrum waterfall, enhanced PC connectivity, and an SD memory card slot. Visit www.icomamerica.com/amateur for more information on ICOM radios.
LDG Electronics provides state-of-the-art antenna tuners for every amateur need. From QRP to QRO, fixed stations, portable and remote, an LDG tuner will match your radio to your antenna using our lightning-fast, proprietary tuning algorithms. LDG is a family-owned and operated company dedicated to bringing innovative, quality products to the amateur market. All LDG products carry a full 2-year warranty that is fully transferable. Support is only a phone call or email away. We're always here to help you. Visit us on the web at ldgelectronics.com.
All right, guys, that's it for tonight. Thanks for being here with us. I'll go back and read all the chat room later. Good night to everybody. See you next week.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.